All right, review for the Geometry Unit 3 quiz. So in the past, we have done problems like this, but we always said, lines parallel to FG containing a certain point. Now we want to look at all the possibilities, which I've referred to in the past. So let's start with FG. That's our reference point. So I'm going to use the red here to highlight it. And remember, I suggest if you have colored pencils, it might help. Now, the parallel lines are going to be here, here, and here. Okay, it's a little challenging in 3 dimensions. This is obviously, most people get this right away, but this is also parallel. It's just parallel on a plane, like a diagonal plane that we don't see. And this is parallel because this is the back side. Okay, so that means we're looking at AB, DC, and EH. Now it says lines here, but they're segments. So I will accept if you put a segment, because in the real world, we're talking about a segment. Okay, so the question could have said segments parallel. I will accept either one, a segment or a line. Just don't put array. All right? Perpendicular to FG. So remember, for perpendicular, we're looking for that all-important right angle symbol. All right? Now, notice, even though GH over here, you might think, oh, that looks like a right angle. There is no symbol here showing you a right angle. Right? Therefore, we cannot assume that. So the only place we see a right angle is here and here. All right? So that means BG and AF. And again, I will accept lines or segments, either one. So BG and AF are perpendicular to FG. Okay, you can't see, but we're assuming GH and BG kind of meet at an angle like that. That's kind of like, slanted out. So even though it looks like it might be a right angle, without the mark, we can't assume. Now, skew to FG. This is where the colored pencils really come in handy. I'm going to mark off my line. And I'm going to mark off anything that is parallel to it, which we've already named. I'm also going to mark anything that is touching FG. So this is touching FG, that's intersecting FG, back there, and back there. Okay? So what is left that is not parallel to FG, but is also not touching FG? And that would be, I'm going to mark them here, CH, BC, AD, and DE. And again, I will accept line or segment on the test for the quiz for these. All right, last, planes parallel to AFGB. So AFGB, that's the top. So parallel to that would be the bottom, DCHE. And remember, use the word plane. Don't lose points on this. DCHB. Sorry, DCHE. And if you want to, you can use any 3 of those letters. Okay, I'm just listing all 4 of them. And some people like to name the entire plane. That's fine when you're talking about a shape. It's up to you. So DCHE or any 3 of those 4 letters would work. All right. Complete the blank for the given pair. So consecutive interior. So remember, for interior angles, if we talk about these 2 parallel lines, this is the inside interior, this is the outside or exterior. Okay, outside these lines. So interior angles, and sometimes it helps to do this, to list what the interior ones are and what the exterior are. 1, 2, 7, and 8. If you do that, it kind of makes it hard to mess these up, okay? So if I'm looking for consecutive interior, my choices are 3, 5, and 6, all right? But consecutive interior also means the same side of the transversal. So the number that's on the same side of the transversal would be angle 6. Alternate interior. So alternate, remember, means skip sides, every other side, opposite side. So opposite side of 3 would be 4 and 6, but 4 is linear pair, so we go down here and look at angle 6 again. Alternate interior to 3. 4 and 5 are also alternate interior. Corresponding to 6, all right? Well, remember, corresponding means one inside and one outside. So if I just slide this one on up, I find it's angle 2. Oops, sorry about that. Alternate exterior. So I'm looking up here at 1. I need an exterior angle that's 7 or 8, but on the opposite side of the transversal, so that would be angle 8. And then let me clean this up a little bit. Vertical angles, angle 7. Remember, vertical angles are formed by basically intersecting lines, an X. So 7 and 6 and 5 and 8 are vertical angles. Well, they're giving us 7, so there's the popular 6 again for an answer. Okay, measures of angles 1 and 2. Well, remember, here is my obtuse angle. If I slide this down, that is my corresponding angle. And since these lines are parallel, corresponding angles are equal. Therefore, angle 2 is 110. And then if you look, angle 1 is also obtuse. It's also formed by an X. Those are vertical angles, so angle 1 is also 110. If by chance, I was looking at this angle right here, that would just be a linear pair, so 180 minus 110 is 70. Okay, so if it would have asked for that angle, your answer would have been 70 instead. Number 11, we have an obtuse angle and acute angle, both on the interior, same side, consecutive. If these lines are parallel, that means those two angles are supplementary. So all I do is 180 minus 63 to find the obtuse angle of 117 degrees. And now there's two ways to find angle 1. One way is just to say, well, angle 1 is corresponding to this angle, which is 63. And another is to say, well, I know angle 2 is 117. So if I did 180 minus 117, I'd get 63. Because they're supplementary. So there's more than one way to figure out these angles. All right, decide if there's enough information to provide that J is parallel to K. That's a little typo here because we have M and N. So instead of writing it down in the problem, I'm just going to change this to M and change this to N. So we're trying to figure out if these two lines are parallel. Well, this angle here and this angle here are marked congruent with the arc marks. Well, that was not supposed to happen. Let's try this again. This one right here, if I slide it down, is corresponding to that one. Okay? So one's inside, one's outside, and the same side of the transversal. So the answer is change your marker first. The answer is yes. And we're going to say because of corresponding angles. And you can just abbreviate. All right, number 13. M and N. So I'm going to actually go back to number 12. I'm going to mark those. Yep, those are parallel. Back to number 13. What we have here are vertical angles. Okay? All we know about the vertical angles is those two are equal. And actually we know that these two are equal. But it says nothing about the two lines. Vertical angles tell us nothing. So the answer is no. Find x. Well, we know they're parallel. We know both of these are interior. They're on opposite sides of the line. And if you look at them and think about it, this is acute and this is acute. And if you remember, anytime we have a transversal with parallel lines, all the acute angles are going to be equal. All the obtuse angles will be equal. So therefore, 10x minus 55 equals 45. Now you got to think, there are going to be times we're going to add them to 180, but that's only one time. That's consecutive interior angles. Every other time, we're going to set them equal to each other because alternate interior and alternate exterior are equal and corresponding are equal. So most of the time, we're going to set them equal to each other. But if they're on the same side of the transversal, they're going to add up to 180. So I'm going to add 55 here to both sides. That's going to give me 100. And when I divide by 10, x is also 10. And I could test that by plugging it in here. 10 times 10 is 100. Minus 55 gives me 45. All right. Here's my transversal. I have parallel lines. These are both exterior, and they're on opposite alternate sides of the transversal, which means they are equal to each other. So I'm going to subtract 12 on both sides, and that gives me 98. And if I plug that in, 98 plus 12 is 110. All right, now we have a proof. Okay, we're trying to prove that that line A and line B are parallel. We're hoping to mark these parallel like this. All right, we're going to use our knowledge of those special angle relationships to prove it. So, I'm sorry, my bad. I just read that wrong. We are told that this is, we make mistakes too. We are told these are parallel. So what we're trying to prove is that angle 7 and 4 are supplementary. Okay, so we start off by saying A is parallel to B, and we just say given. So we're trying to prove that this obtuse angle and this acute angle are congruent. Now, we can't say they're congruent by alternate interior or exterior because we have one of each. So we kind of need to move down the line. And there's multiple ways to do this. Okay? There's not one way to do it. Right? And we'll talk about various ways to do this. So, what we could do is say that angle 7 and angle 5 are congruent. Angle 7 is congruent to angle 5, and we know that by corresponding angles. Okay? We know that angle 5 and angle 4 are supplementary. And we say that's because of the definition of linear pairs. Angle 4 and 5 form a straight line, so therefore 4 and 5 are supplementary. Well, if 7 is congruent to 5, and 5 and 4 are supplementary, then we know angle 7 plus angle 4 are supplementary by substitution. Okay, we substituted right there, 7 for 5. All right, if you'd like to see another way of doing it, okay, I just copied that page over. I'm just going to look at this part here. So another way to do it would be to say this angle here, angle 7, and angle 2 are supplementary. Okay, and that would be the definition of a linear pair. Okay, definition of linear pair. Then we know that 2 and 4 are congruent. Corresponding angles. You can see we're writing the same thing, just in a different order, going a different route. All right. And once we know 2 is equal to 4, and 7 and 2, kind of like what we did before, we're going to substitute and say angle 7 and angle 4 are supplementary by substitution. So there's more than one way on these proofs to do it.